Welcome back. And today on Module 1, Lesson 10, we're going to continue our work with the distributive property, building on what we learned about in Module 1, Lesson 9. But we're going to introduce a little bit of new material. We're going to use parentheses, and we're going to use that to help us show that we're breaking apart one fact into two smaller facts, or two different facts, rather, not necessarily smaller, in order to solve. So let me go ahead and share my screen again, and we'll talk about exactly what that is going to look like. And we'll use familiar problems, similar ones to what we did in Module 1, Lesson 9. Well, let me start with, we'll do 7 times 2. I think that's the one we started with last time. And I'm again going to break that into 5 times 2 and 2 times 2. We'll set this up just like we did last time, and then I'll show you the difference, the increased level of complexity that we're adding here in Lesson 10. So this bottom part is 2 times 2. We know that's 4. And the top part is 5 times 2, and we know that that is 10. 5 times 2 is 10. And again, our whole thing is 7 times 2. So this should look familiar. This is exactly what we did in the last lesson. And what we're going to do this time, I'll do it over here on the right, and this is what you'll see on your problem set in your exit ticket in your homework, is 7 times 2 equals 5 times 2. We're going to put that in parentheses, and a parentheses is just a way of grouping something together in math, plus 2 times 2. And again, we're going to put the 2 times 2 in parentheses as well. And again, those parentheses are just grouping something together. So it's showing that we do this together, we do that 5 times 2 together, and we do this 2 times 2 together first, and then we add them together. So the next step would be to rewrite this as 7 times 2 equals, so I'll keep the colors consistent here, 10 plus 4. And then finally, we have 7 times 2 equals 14. So again, the model over here is exactly what we used in Lesson 9. The increased level of complexity comes with writing this out using parentheses. Let's do another example to gain some more exposure with that. This time we'll do 6 times 3. So let me do 5 rows in black here. So this is 5 times 3. And we'll add 1 more row to get our total of 6. Our whole thing is 6 rows of 3, and that's what we're solving for. Don't know what that is yet. So 5 times 3, we can count by 5s for that. 5, 10, 15. We counted by 5s 3 times. And 1 times 3, 1 times anything is itself. So 1 times 3 we know is 3. And now we get to the part where we need to use parentheses. So we can solve it just like this. 6 times 3 equals, we're going to put each portion, each different color from our array here inside their own parentheses. So we had a group of 5 times 3. And again, that's just showing these first 5 rows that are in black. And then we're going to add that to our bottom row here, which is 1 times 3. And because that's all one group, we're going to put that in parentheses as well. Again, these parentheses are just ways of grouping things in math, making sure those things are done together. And so 6 times 3, oops, wrong color here, there we go. 6 times 3 equals 15 plus 3. And then we could say 6 times 3 equals 18, because that is the product. 6 times 3 is 18. And again, we use those parentheses to show these different sections, these different colored sections of our array. And we can do that same thing with those model we used last time where we make a bigger array and then subtract from it, the same thing that we did in Module 1, Lesson 9. So let's use an example like that and show how we can use parentheses in this way. We will do, I think we did 9 times 2 last time. We'll do that again. We'll use a familiar example in order to show this. I want you to really be able to focus on the parentheses part. So I'm giving you familiar examples with the arrays. That way it's not all the parts are totally new to you. So again, if I'm figuring out 9 times 2, I'm going to draw 10 rows first, and I'm going to subtract from it. Again, I'm doing that because it's pretty easy to multiply by 10. That's a familiar fact. 8, 9, 10. So I have 10 times 2 here in red. And we know that that equals 20 because we take the factor that's 2 and add a 0 to it essentially. And then in black, I'm going to cross out one row of 2. So I crossed out 2 total things. And so my equation then becomes 10 times 2 in parentheses minus 1 times 2. And again, that goes in parentheses too. Again, we're grouping the 10 times 2 because that's our first step. And then we're subtracting what's in the second set of parentheses. That's 1 times 2, that row we crossed out at the bottom. And that's going to equal the total 9 times 2. So 10 times 2 we found was 20. We do the things in the parentheses together. So 10 times 2 is 20. Minus 1 times 2 is 2. And that equals 9 times 2. So whatever's on this left side of the equal sign is going to equal what's on the right side. So 20 minus 2 is 18. And that equals 9 times 2. So the solution to 9 times 2 is 18. Let's do one last example of that, and then I will send you off on your own. And we will do, let's do 7 times 3. Four rows, 5 rows. I'm going to make 10 rows again. Add one up at the top here for space. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 10 rows of 3. And again, the problem I'm trying to ultimately solve is 7 times 3. I then need to cross out 3 rows because 7 is 3 less than 10. So I need to get rid of 3 rows of x's. 3 times 3, 3 groups of 3. And we know that that equals 9. We know that 10 times 3 equals 30. Again, you take that factor that's not the 10, and you add a 0 to it. So 7 times 3 equals, in parentheses, 10 times 3 minus, because again, we're not adding these things to the array, we're taking them away, minus 3 times 3. And again, that goes in parentheses because that's all grouped together. Okay. 7 times 3 equals 30, because 10 times 3 is 30, minus 9. And finally, 7 times 3 equals 21, because 30 minus 9 is 21. The thing you have to be careful about here is making sure you do this in the correct order. You always have to, you're going to subtract the smaller amount from the bigger amount. So you're going to take the entire array, and that's going to come first, and then you're going to subtract the smaller portion, the portion that you took away. It won't work if you flip it around and go the other way. So you have to start with the whole array and then subtract the amount that you're crossing out or the amount you're getting rid of. So again, this just shows that you can take a fact like 7 times 3, you can extend that array, make it bigger to use a fact like a tens fact, for example, and then subtract out the extra, the stuff that you added to it to solve that fact that you didn't know originally. Again, both of these strategies, whether it's breaking an array into 2 parts or extending an array and then subtracting, are great strategies for using facts that you already know to solve facts that you don't yet know. Again, as always, please ask questions if you have them, and I'm happy to do my best to answer them for you.